In this video, I'm gonna focus on some kinematic question. A car starts from rest. So car start from rest, it means U initial velocity is equal 0 and accelerates uniformly. So it means A is equal constant number to reach a velocity of 20 meter per second. So our final velocity is equal 20 meter per second. South, so it's direction in 10 seconds. So this is time. Calculate the car acceleration. So we need to find A. Because acceleration is a vector quantity, so we need to talk about magnitude and direction. So I consider south direction as my positive direction. Okay, so right now, I need to find out my acceleration. The formula that I need to use is definition of acceleration, that is final velocity minus initial velocity divided by t. I don't have acceleration. I have my v, I have u, and I have t. Just I substitute number in this formula. So v equal 20. And as I said, south is positive. It means v, so it's positive number minus u is 0, time is 10. So it's equal 2 meter per second squared. And as it's positive, so it means the direction of acceleration also is south. This is the answer for part A. Part B, calculate the velocity of car after 20 seconds. So after 20 seconds, what's the velocity of car? So in this case, we want final velocity while we have acceleration and time. So we can use formula v equal u plus at. So v is something that we need to find out. So I just put v, u is initial velocity, that is 0, plus a that we just calculated is 2, and time, because it asked after 20 seconds, I put 20. So v equal 40 meter per second, and as it's positive, so it means the direction again is south. Part C, calculate the displacement after 20 seconds. So this time, they're asking for delta S. Time is 20 seconds. So the formula that we know for S is ut plus half a t squared. So we see we have our u, we have t as it's given, 20 seconds. You calculated a at part A, and t we have it. So we can substitute number again here. U is 0, so it's 10 plus half that we calculated, it's equal to times 20 squared. So as a result is 100 meter, and as it's positive and we define positive as south, so it's south. Okay, let's go through another question. Next question, a car is traveling at a velocity of 60 kilometers per hour. So this time, the velocity that we have is 60 kilometers per hour. So definitely we need to convert this one to meter per second. And the direction is north. So I want to consider north as positive. And when he sees a kangaroo on the road 60 meters ahead, so the driver sees a kangaroo 60 meters ahead. Okay, it takes him 1 second before he hits the brakes. So this 1 second actually is reaction time. Reaction time. The car decelerates at constant rate. So deceleration is constant rate. Maybe it's helpful information, and it stops after 5 seconds. So our final velocity here is 0 and time is 5 seconds. Determine if the driver hit the kangaroo. So something that we need to do for this question, we need to see in this 5 seconds how far the driver moves, how far they travel. And if it's about 60 meters, it means it hits the kangaroo. If it's less than 60 meters, it means it doesn't. So something that we need to do, we know definition of average velocity. So V equal delta S, that is displacement, divided by T. This is the definition of average velocity. So right now, average velocity, how we can calculate our average velocity in this case when we don't have acceleration, we don't have enough data for doing that. But we know we have our initial velocity U, that is 60 kilometers per hour, and we have our final velocity equals 0 meters per second, and we know it moves at acceleration is constant. So when A is constant, always remember the average velocity also is initial plus final velocity divided by 2. So something that here I can do, actually I can find my average velocity V equal U, that is 60 kilometers per hour. So first, see, I convert this one to meter, 60 kilometers per hour. If I want to convert it to meter per second, I need to divide it by 3.6. That is equal 16.67 meter per second. Okay, then this is my final velocity, my initial velocity is 16.67. My final is equal 0, and I need to divide it by 2. So as a result, my average velocity is 8.33 meter per second, and same direction, that is north. Okay, I have my average velocity and I have my time. So I can find delta S. Okay. So I say V equal. So in this formula, just I write it 8.33 equal delta S divided by 5. So this delta S actually is equal 41.67 meter, again north. But we shouldn't forget that it takes the driver 1 second before he hits the brake. So before hitting the brake, the driver travels 1 second at velocity of 16.67 meter per second. So actually, delta S total is equal delta S before hitting the brake plus delta S after hitting the brake. This one is after hitting the brake. But what about before? To calculate this one, something that we need to do, we say, okay, it was constant speed or velocity at 16.67. So just I put V equal delta S divided by T, and V was 16.67 time just 1 second, and I can find this delta S, that is equal 16.67 meter north. Right now, our delta S total becomes this one, plus this one. This is our delta S total. So delta S total is equal 14.67 meter plus 16.67, that is equal 58.34 meter. So after traveling 58.34 meter, actually the car stops. How far was the kangaroo? 60 meter away. So as a result, it doesn't hit the kangaroo. Okay.